Welcome back. If you remember that the balanced equation is one of the most absolutely important things in chemistry, from it you can figure out almost anything in terms of amounts of product from amounts of reactants or amounts of one reactant as it reacts to another reactant. And we're going to see that this is expanded now that we know the definition of molarity. So if you remember the definition of molarity, it's the concentration of a solution. So we have moles of solute, something dissolved, in liters of solution. That's the total amount of solution including the solute. So we know that the balanced equation is all a proportion of number of moles. So we're going to use this formula to find moles of solution if we know its concentration and its volume. So just to review what we're going to do, we're going to take the volume of something and we're going to turn it from the using the formula above, we're going to turn it into moles of that solution. Then go through the balanced equation to see what its proportion of moles to something else that we're interested in. Once we get that number of moles, then we can use this same molarity formula to turn it back into the volume of the second solution. So let's do an example. One of the solids in a photographic film is silver bromide. It's not water soluble, so we can prepare it this way. We've got silver nitrate, which is aqueous. We've got calcium bromide, which is aqueous. But when you put it together, silver bromide is insoluble, and so it falls out. This is one of our precipitate reactions that we looked at before. So here's the question. They're going to give you a concentration of the calcium bromide, and we want to know how much of it we're going to need to react with a certain volume of a specific concentration of the silver nitrate. So they're going to give us a concentration and a volume of the silver nitrate. We don't have moles, we'll have to find it. Then we're going to go from moles to moles of the calcium. Then from moles, we're going to go back through the molarity formula to find the amount that we're going to need. Okay, so we need moles first. We're given mils and we're given the concentration. So first of all, we know that in 0.115 moles and 0.05 liters, when you multiply those together, we're going to get 0.00575 moles of the silver nitrate. So here's our balanced equation. We always start with the balanced equation. And so we're going to start with what we have, 0.00575 moles of silver nitrate. And now that we have moles, we can go through our proportion. We have moles of known over moles of unknown equals, now go from the balanced equation, 2 moles in this case of silver nitrate to 1 mole of calcium bromide. And now we're going to find the moles of calcium bromide that we're going to need to react. And we find that it's 0.000288 moles. So now that we know moles, we can put it back into its molarity. So I know that molarity is molarity equals moles over liters. So you fill it in where we know. It told you what the molarity of the calcium bromide solution was in the problem. So 0.125 molar calcium bromide solution is 0.00288 moles over what? What are we going to need for that? So we just switch it around. We put the liters on the top and the molarity on the bottom, and we're going to get an answer of 0.0230 liters. And the question asks you to put it in milliliters, so you're going to have to multiply that by 1,000 to do that. And your answer is 23 milliliters. This may take going over and over again to where you can understand this. This is a very important concept. I hope this helps you.